All right, Rehab Ruthless is new to this LED stuff, wanting to do basic light setup around the house and each window. Where to start and what will I need? Basics of what you need. I mean, watch that video. This one, Beginner's Guide. Now, there's a lot of follow-up videos here that people don't often watch, but there's a lot of good information in there. So, in fact, the stuff that I'm going to talk about today is mostly in this video right here already. In my experience with answering people's questions about LEDs, there's two things that probably come up more than anything else. I think the first problem that more people face than anything else is the flickering, or it's just random, or just some things are blinking, or some things are just wrong color and they just kind of go on and on. So it's not always just flickering. Sometimes it's just things are just being crazy. That is almost always a data signal problem. Typically, the problem in that situation is that your wire from your controller to your first LED is too long, or the wire's too thin, or whatever. There's too much voltage drop, too much resistance. And so the signal, the data signal coming from the controller, getting to the first LED is too weak. For one reason or another, that signal is corrupted and it's not getting to the lights and telling them what to do the right way. Now, this was prior to everybody having pretty easy access to the DrZz. When I made this video, you still had to solder your own DrZs together. The DrZs puts in a logic level shifter. And what that does is basically strengthens that data signal. When the controller sends the data signal, it goes to the logic level shifter. It gets a big boost in voltage, and then it sends it out to the first LED. And because it's passed through that logic level shifter, it can go a long way, even in a small wire, and it will get to the first LED nice and strong, nice and clear, and your LEDs will do what you expect them to do. If you were just putting it straight from the controller, then you had to keep that wire from the controller to the first LED really short. At this point, because the DrZs are so available, well, they are more available. And we're trying hard to make them more and more and more available, but because they're so available, I don't think going straight from a Node MCU is the best solution anymore. However, there is another solution too that I've used, and that's what I showed in this video, and that is to sacrifice one pixel. Basically what you do when you're doing a sacrificial pixel is you're taking one of your LEDs and you're using that as a logic level shifter. So you can use something like this. This is a logic level shifter. So in the Hyperion video, I show you how to wire up one of these logic level shifters if you wanted to use this. But honestly, I don't think this is gaining you anything that a sacrificial pixel wouldn't. And the sacrificial pixel is going to be a lot easier to wire up. Let's go through what is a sacrificial pixel and how I would recommend that you connect it. But I'm going to assume that for this situation, you've got a regular controller like this, okay? You just watched that video from last year and you got a Node MCU. So you got a string here of 12 volt pixels, which by the way, at this point, I think I would, when you're talking about these kinds of pixels, I would just go with 12 volts. It's just going to make your life a lot easier. Just do 12 volts. You'll have less power injection, and you might save a few bucks if you go with 5 volt pixels like this, but in the hassle in the long run, you just get 12 volts. So this is the beginning. All right, it looks like that. That's the beginning. If you're not sure whether or not it's the beginning, you can look on the pixel itself. There, DI. Oh my gosh, it's working. So right there in the middle, you see that white, the white wire is going and it says DI. That's data in. That wire is connected directly to this. So this is the data in direction, okay? Some pixels have an arrow, some pixels don't have anything. If they don't have anything on them to mark them as the direction, if it doesn't say D in, if there's no arrow, then almost always, at least in every situation that I've seen, it is the data in side is on the opposite side of the board as this big black chip. Okay, there's a big black chip here. The data in is the opposite side. So this is the data outside with the big black chip, and this is the data inside. Most of the time, you should have some kind of a marking on the circuit board, this little circuit board in here that you should be able to see, arrow, DI, something like that. But if you can't see it, this is a pretty good indication. Now, if you don't see it and you can't tell what side's what, just connect it. As long as you've got plus and minus, don't mix up your plus and your minus. Make sure that your red is your positive and your white or blue, whatever it is your negative. Don't mix those two up. But if you connect the data in to the output side, it's not going to break them. So if you connect it doesn't work, just connect it to the other side. But generally, you should be able to see what it is. All right, so now back to my sacrificial pixel. Just cut off one of these pixels. Now, if you have extra connectors like this, then you might be able to use some wire to make an extension cord, sort of. So if you've got another female-male connector set like this, then you can make an extension cord. Then I would suggest cutting off the last pixel here and connecting this pixel on its input side right next to your controller. Okay. Then extend your connection, make your extension cord, basically with just 3 wires, a 3-wire cord and 2 connectors, and make an extension cord that goes from here to wherever your first LED is going to start. But perhaps you don't have extra connectors. In that case, just take the very first pixel right here, just take the very first pixel and cut it off. Boop. And I'm going to do that because I can. Now what will happen is we're going to connect this input side to the controller right away. Okay? That'll connect to there. Then we've got these 3 wires here. And what we're going to need to do is to splice in 3 wires like an extension and splice it into this second pixel way out here. Okay? So you'll need some kind of long 3-cable wire. How long do you think it can reach? And we tested it and we went 40 meters. We sent the data signal 40 meters before we started getting flickering. And that was like 22 gauge wire. So you can go a long, long way. But here we are, sacrificial pixel time. Okay, sacrificial pixel, that's going to be this guy. He will be our sacrificial pixel. We're going to just strip out these wires here. What we did was we tied these together. Okay, I just twisted these up together. Now the other end of this wire. So here I've got my sacrificial pixel, and I've got one end of my long 3-conductor wire. So I just connect these up ground to ground, data to data, and voltage to voltage. If you find yourself in a situation with flickering, this is a great solution. You take 1 pixel. This connection here will go right to, you can't just plug it in there, but basically, right? Just pretend that that's going to be okay, even though it's not. And the first pixel is right there next to the controller, okay? Then you can have a long wire, as long as you need, really. Unless, like I said, 40 meters we did on that other live stream last year and made that short video out of it. And then you can go all the way to the second pixel. You can go a long, long wire all the way to the second pixel. And now you shouldn't have any issues. You shouldn't have any goofiness. Makes me sad that you aren't using Quinn LED board. Oh, Paul, I'm doing this for people who don't have it because you don't need to do this with a Quinn LED board. If you just want all your problems solved, just get a DrZz and you're fine. And it's a decent example of saying, well, if you don't want to do all this, then you can just get a DrZz. When is your next group of DrZz back in stock? Okay, Matt, great question. I got a big old shipment. There should be enough to get everybody through. At least by the time we finish releasing all of these, there should be another batch in. So we're hoping that we're done being out of stock. But we've hoped that many times, haven't we, Quindor? We keep talking about this and we keep saying, man, okay, this time we got to have finally kind of saturated the pent up demand, right? Now it's just going to be sort of a normal steady flow. But no, not yet. So if you want it from the UK, Matt Harry Spark, that's Quindor. So you go to Quinn LED, and I have that right here as well. Devices are available for international customers at this. How to run 2 strips with a DrZz. You can just split the data signal and run this to another strip of LEDs. But if you did that, then they would do the exact same thing. If you don't mind getting the exact same thing, then that's what you do. If you want them to do different things, then you have 2 options. One is get a DrZz quad. The other is to get 2 DrZs. The other topic for the day was the power injection. And I was hanging out with some buddies last night. And I was talking to my buddy Matt. He was confused about power injection, and he's a smart guy and an engineer guy. And so I thought, okay, well, I'm either not explaining it very well or something, because if Matt's confused about it, I know a lot of other people get confused about it as well. So what the heck is voltage injection? Why do you need it? And how do you do it? Okay. Let's first, we're going to make a distinct separation between the data signal strength issue, meaning how far can you be with your first pixel from your controller. That part is handled by using a DigQuad or DigUno, by having a logic level shifter, which is a pain in the butt, or by having a sacrificial pixel, which is a little bit less pain in the butt, but not as good as a DigUno or DigQuad. Okay, so that's one issue. Data signal strength, that's flickering, basically. The voltage drop issue is different. When you hook up a bunch of these LEDs, each one adds a little bit of resistance. So the voltage, as you go along the string, starts to fall. It's okay if it falls a little bit, but at some point, when you've got enough LEDs or a far enough length, the voltage will drop too much for it to effectively, or for the LEDs to effectively function. What you will see primarily is dimming or maybe a little bit of color distortion. And what I mean by that is sometimes you'll see, well, in the extreme, if you set your LEDs to white, in the extreme, when you really need voltage injection, they will start to turn orange and then red even at the end. And what happens is there's not enough voltage for all 3 of the colored LEDs on there, because you've got a red LED, a blue LED, and a green LED. There's not enough voltage for them all to light up. And I don't know why the red one does, but the red one does. And the others don't. So if you've got a long strip of LEDs, a long run of these, and at the end you're starting to see the colors turning a different shade, getting a little darker, getting a little more dim, then probably what you need is voltage injection. In my experience, with 12 volt pixels like this, you can have probably 250 pixels, which is 5 5-meter strings. So 25 meters, which is going to be in the ballpark of 80 feet, maybe something like that, of these. The feet and the distance, the meters, total meters, matters less than how many pixels you have, okay? Because each pixel adds a lot more resistance than just another foot of wire. So that's how you know if you need voltage injection. You need voltage injection if at the end of your string of LEDs, you start to see dimming or you start to see color changing. You could see some flickering, but generally dimming and color change is what you're going to see. If that's the case, then you need voltage injection. How do you do voltage injection? Easy peasy. I always say that. It's not always easy for everybody, but I say it anyway. For voltage injection, you just need a pair of wires. This is just like 20 or 22 gauge speaker wire, all right? It's rated for 12 volts. It's probably decent to handle, 5 amps, something like that. What you do with this is you connect it to your power supply. So let's get out a power supply. I was playing around with this power supply when we were hooking up some extra lights on my house. And this thing is, bare bones here. And I had it plugged in and I touched something under. I picked it up. It's just a stupid thing to do, but I picked it up and it zapped me. I'm not going to plug it in, okay? I'm just going to use this as an example of connecting to your power supply. So on this power supply, you may be able to see that there are 2 positives and 2 negatives. It doesn't mean that there has to be on your power supply, but in this case, there's 2 negatives over here and 2 positives over here. So I've got 1 pair of wires here, and we could take this pair of wires and it would be connected to you could connect it to the input on your DigUno or your DigQuad, or you could connect it to the beginning of your LED strip like this. I can just connect it here. Okay, so that would be 1 power supply. We're giving power to the beginning of the LEDs. Now, If we're having the dimming at the end of the LEDs, then we need to use these other connectors. Put the plus there. Okay, so now we've got another pair of power wires. This is just supplying the power wires, or just the 12 volts. And we can take that to the far end of the LEDs. This is the opposite end, right? This was the start. This is the end. This is the finish. And this wire then would just run parallel along with this all the way down. Okay? And we just splice that in to these extra wires at the end. All right? We just splice this together. Bingo. Now what we've done is we've boosted or injected another 12 volt supply to the far end of the string of pixels. Prior to doing this, if we were to measure the voltage at this end here, it might be 10 volts or something, okay? Assuming that these were dimming. Because this is just wire coming from the power supply, there's very little resistance. There's some, but there's little resistance. So when this wire, if you measure the voltage on this wire, it'll be 12 volts. When you connect it to these, now these LEDs are seeing 12 volts again instead of only 10. And they get bright and they stop showing the wrong color. All right? And it doesn't have to be at the end. It can be anywhere. Say you're in the middle of a string here, right here, and all of a sudden, you notice that they start to get dim and you want to do it. You just split these apart. I'm not going to cut them, but you just split this apart and you do a connection with your ground to your ground and your positive to your positive, and it does the same thing. Basically, you've got lower voltage here. It should be 12, but it's not 12. It's only, 10, 9, something too low. You take these wires, which are carrying a full 12 volts from your power supply, and you plug them in, boop, to the positive and negative, anywhere along the string. And that injects 12 volts. That's voltage injection, and it boosts it back up to 12 volts for all these LEDs in that area. Okay? Yay! All this that I'm talking about, I've done it before. And I'll do it again, but I have done it. I have done it. There's 2 that talk about this. There's one video from last year that was a similar kind of thing. It was a live stream like this, and I chopped it up into a shorter video, which I'll probably do with this one. That's this one, and that'll talk about these issues as well. And I actually even did one a really long time ago. This one. I didn't know as much then as I do now, but this one has a lot of good information. And I show you in this one what happens when you don't have power injection. This is what happens. This is what it looks like when you don't have power injection. They start out fine, then they start to turn some sort of yellow-orange, and then they turn red. And when you do power injection, now they look like this. And this was power injection with power going to the far end, so now they turned white. But what you see is this one is getting, these are only 5 volt pixels, by the way. This is getting 5 volts. This is getting 5 volts. These ones are getting a little bit less, because with these pixels, if you get 5 volt pixels, after about 50 pixels, you need to put more power in. So the 5 volts, it's not that it drops faster, it's just that the pixels need a minimum voltage. And if you have 12 volts, they get their minimum voltage for a long time. The minimum voltage is somewhere around 5. So if you're starting at 5 and you drop much below 5, you're going to have problems. But if you're starting at 12, you can drop a long way before you get too low for the LEDs to get the voltage that they need. There's another thing that you can do if you're having power injection problems, if you're having problems with the lights getting dim or changing colors, you may be able to solve that by just turning down the brightness. Okay, we're going to sign off like it's Halloween. Okay? We're going to sign off like Halloween. Okay? Ready?
As always, thanks for watching. Until next time, adios.
I think she won this creepiest. She did this like little creepy doll thing. Okay, everybody. We'll see you next week. Take care. Adios.
See you on next Sunday.
Oh man, I'm scared.
Bye.
I'm scared. I'm scared of you. Yikes. If you need help or want to chat with me or others who also enjoy projects like this, you can find us on Facebook and Discord. If you like what I'm doing and you want to support me, You can use my special product links in the video description, or head over to Patreon, or just like and share my videos. That's easy. If you like this video and you want to see more like it, this box will take you to a playlist of some of my favorites. In addition to videos like this, I also do live streams every Sunday. This box will take you to a recording of the latest live stream. That's all for now. Adios.